I think more generally what I think we do with high luminosity is really we shape not only the forefront of high energy physics but also the one of CERN as an organization in two ways. One of them is we're really building the next generation of the machine, which is really going to be the workhorse of the next generation of physicists. And while doing that, I think we have also helped and facilitated, pushed the boundaries of technology, developed a lot of new technologies, niobium-13, magnesium diboride, crab cavities. And all of these are already today actually fundamental cornerstones of even the projects that come after high luminosity.
I followed the project since the beginning. Actually, before the project started, before the real contribution started, I was in charge for a few years of the R&D program called LARP. Very useful to create the collaborative spirit which we're still witnessing inside HiLumi. And probably the big moment there was during the R&D when we were able to make these magnets, focusing magnets in this new technology, niobium-13, and make them successfully, make them work. So at that point we shared the results with the whole world, with CERN, and that allowed the HiLumi to become more and more defensible as an upgrade of the LHC to increase the luminosity.
I think that the largest achievement in my area was related to these superconducting magnets that we have designed, because they are combined magnets, and so there is a large torque, a large mechanical torque, and it was very difficult to overcome this problem in the first prototypes. So after two magnets we have to make a major change in design, and it was successful after this change, but it was really a large effort with my colleagues that we were able to solve it.
CCT magnets have never been used for a real operating accelerator. High luminosity LHC is the first time adapt this new structure, superconducting magnets. When we produce these magnets, we are facing some challenges like long training problem. This has never happened for other type of magnets. But finally we found a solution and overcome these challenges, and now everything going well.
I'm really proud of the teamwork we had in Milano at LASA, pursuing the effort to test so many magnets. We produced and tested 54 magnets, which is quite a bunch. And it was almost 3 years of work, continuous work from all the team, and it was really a challenge, and we succeeded.
One of the challenges I thought is the COVID era. At that time, we just entered the phase of the 7-meter long magnet production. We, KK, was responsible for the design and the construction of the magnet part, but some detail of the interfaces are not determined yet. So we had some difficulty, but we overcome that kind of the issues, and then finally we succeeded to deliver the magnet. So that was, I'm very proud of that.
During the construction phase, of course, we had several ups and downs. Magnets are built, they work, so we are cloud 9, some of them don't work, we are cloud 0, and all in between. Similar thing with the cavities that we are contributing to HiLumi.
In the past years we did a lot of preparation of our infrastructure in order to be ready to produce these cryo modules. And we received a cavity in the beginning of this year, which was really exciting because we could actually test everything. And we realized that our infrastructure is ready for the series production. The biggest challenge was that we have to focus on our big project internally, and that had impact on the HiLumi project. And we could, together with CERN, actually find a mitigation strategy in the past year, which was quite some effort, but I'm really proud of, and I'm really happy that we have now a plan forward in order to deliver the cryo modules on time. Really thankful to CERN.
We built the first RF dipole crab cavity cryo module and delivered that. When it arrived at CERN, there were some problems with it. Thankfully, these were repaired and resolved, and it managed to achieve the first horizontal crabbing of a beam in the SPS.
The first crabbing that happened in the LHC, and we did it through head-on beam-beam interaction, which is super nice to be able to detect it for the first time. And this was very nice because obviously it's It's a real thing that you can see and that you can test in the machine, and it's very important in preparation of the installation of the crab cavities.
The biggest achievement we had was the first test of a coil powering system of the type needed for the triplets, which is a system able to transfer over a length of about 80 meters, a total current of about 100 kA by using novel high-temperature superconducting materials.
We achieved the installation of the whole string, so it's not anymore to show the 3D printed mock-up, but we have all the elements. The IT string is there to prove that all the installation procedures and all the components, they are working together correctly. And of course, during these last couple of years, we learned a lot. The priority for me is now powering all the circuits together and to learn from this as much as we can.
It probably has to be the organization of the preliminary design review for the HL dumps. And it was a quite important step because it really marked the transition from the R&D phase that lasted 3 years, from 2022 to 2025, on to the series production phase.
We approved integration of 0.5 for the tunnel, which was a big milestone. And actually for us, LS3 is already started. We already started to change some infrastructure in the LHC and also the installation in the new galleries of HL.
I think pushing even a little bit the boundaries of technology takes a lot of time, takes a lot of effort. And I think there have been a lot of lessons being learned that took time, energy, resources to overcome. And I think this is really an excellent achievement of these past 15 or 20 years of work.
When I came to CERN in 2015, so I started in the project in 2015, most of the components were still in the preliminary design, let's say. So really in the conceptual preliminary detail design. So we should all be very proud that 10 years later that we see most of these components already produced, fully validated, and in many cases ready for being installed in the machine. So this, I think, is the major achievement and the main goal of this project. So we all should be proud of it.